Triangle proportionality theorem. You don't need to memorize this theorem, but we need to make sure we can understand what it is that it's talking about. So the triangle proportionality theorem says if a line is parallel to one side of a triangle and intersects the other two sides, comma, then it divides those sides proportionally. This is exactly what I was just talking about over here. So if you want to make a little diagram, I guess I should probably do this on the actual slide. So it's on there for the world to see. So if you remember what I just showed you, if we have a triangle, we have a line that is parallel to the third side and intersects the other two sides, then it divides it proportionally. So if I had A, B, C, D, E, then my proportion would be AB over BC, which AB is physically over top of BC. AE is physically over top of what? ED. And since they're proportional, we would set those equal. That's what this theorem is telling us. So we're going to write it as we see it. That's up to you.
It can be anything we want.
Yeah. Huh?
It can be anything we want it, or just.
Well, for the most part, anything you want, yes.
Okay.
As long as you see it in a not incorrect way. Make sure you see it in a correct way. Huh?
Sorry.
No. It's okay. You're allowed to cough.
Alright.
All right, so if we look at this first example, do we have a line parallel to a side of a triangle? Yes. Is that line dividing the other two sides into parts?
Yes.
Yes, it's dividing it between TS and SR, TU, and UV. Okay, now just for this example, I'm going to write it all out. You do not need to do this for every problem. So if we set up our proportion, TS would be proportional with what?
TU. No. I mean SR.
SR
Sorry. That was close.
is equal to TU over UV, would be our proportion.
Equals.
What is the length of TS?
5x.
X. SR is 16. TS is 5 over 10. Now this one's a little bit obvious, because what's true about our proportions? Well, don't think plus 5. It's half, right? 5 is half of 10, so what can we assume x would be? 8. Let's cross multiply that. 10x is equal to 80. X is equal to 8. Okay? Now, the reason why I'm saying write it as you see it, what do you see x physically over top of? 16. So if you think about it as turning that into a fraction equals that as a fraction, you just write it as you see it.
Oh, okay.
Right? X over 16, 5 over 10.
You're right.
Would it be incorrect if you saw it this way? X over 5 equals 16 over 10. No, because if I write it like that, if I do x over 5 and 16 over 10, do we still get the same cross products as we did over here?
Yes.
Yes. Okay. So however you see it, as long as it's correct in a way you see it, but I see it this way. Okay? All right. So now what happens if we had our triangle, we had our parallel side. What if I bring in a third parallel line and take off the top of that triangle? and then continued these lines as such, and continued this line. Excuse me.
What that is?
I did not do a very good job with that. Do we still have a division of sides?
Oh, like that.
Yeah.
Yeah, I've got a division here. I got a division here, here, and here. So this is what the next thing that we're going to be talking about. It doesn't really have a specific name, so you don't have to worry about it. Just write this in the box. If we have 3 parallel lines, so if 3 parallel lines, intersect 2 transversals, then the segments intercepted on the transversals are proportional. So here we have our 3 parallel lines. Remember, a transversal is just a line that intersects more than one line. So here we have 2 transversals. So we still are going to have proportional parts. So if I were to label this A, B, C, D, E, G, AB would be proportional with what? So AB is over what? BC is equal to DE over what? EG. Good. Write it as you see it. This is physically over that. That's physically over that. What if, you don't have to write this in your notes. Oops. Just watch. What if I gave you the proportion AC over BC is equal to blank? What would go on the other side of that proportion? DG over EG is correct. AC is the whole thing, right?
Yeah.
So DG is the whole thing. BC is the bottom division, so that means EG is the bottom division. Good. All right, so let's go ahead and do this next example. Let's write it as we see it. Yes. Let's solve for x first. So to solve for x first, I'm going to ignore this top half. Write it as you see it. 15 over x equals what?
26 over 30.
26 over 30. Is everybody okay with how we set that up?
Yes.
Cross multiply. 26x is equal to 450. Divide that by 26, Zach.
17.307. 17.307, and I wish someone would stop interrupting me.
I did say Zach on his behalf.
Pretty sure your name's Seth.
We're okay. So that would round to what? 17.4 approximately? All right. Now let's get y. So ignoring that x part, so ignoring this bottom half, let's write it as we see it. How do you see it, Will?
Why did the equal sign sort of?
Wow.
Because it's approximately, I rounded it.
Isn't it just 16?
Will, how do you see it, Will?
Well.
Which part?
To get y at the top part. What?
16.5
Over.
y.
No.
No, wait, 15?
Sure.
There you go.
Equals.
So you do really,
You do
y
really
over,
write it how you see it,
y
yes.
over 26.
Good.
What do you do?
That's so weird. It's just like
Cross multiply, 15y is equal to 429, divide by 15,
28.6.
and it's exactly
28.6.
28.6. Yeah.
Why wouldn't you do 26 over 15 equals 30 over x?
26 over 15 equals, oh, for the x one? You could, Seth, or Scott, you would be totally fine doing it that way too. If you did 30 over x, 26 over 15 would work. Just don't do 30 over x equals 15 over 26. But you're still going to get the same cross products. Okay? All right, flip on to the back.
Dude, did you know that they wanted it?
So the last two,
I think there's only
Dude,
one.
did you know they actually
Yep.
wanted to
There's-
use,
I know. guys,
Fight the
focus.
dust or
You're almost done. The
Yeah,
previous
pretty
two theorems that we just talked about dealt with parallel lines. The last one we're going to be dealing with talks about what happens when we have an angle bisector.
Left to right.
I'll give you $1 if you write that for
If A ray bisects an angle of a triangle, comma, then it divides the opposite side into two segments that are proportional.
Oh my god, Miss Crowley, spell that one out.
Proportional
Thank you.
to the other two sides of the triangle. Period.
First time we've ever caught up with you.
Oh,
All right. So we look at the last example.
Miss Caroline, can you put that up there?
Yeah, go ahead.
Thanks.
no.
So remember, bisect means what again?
down the middle? Down the middle.
Cuts it into half. So if a line is an angle bisector, then it creates two congruent
Side segments.
angles, angle
Okay.
bisector. So it means the angles are being split in half. So when we have an angle bisector, we're going to again get proportional parts. And we are going to write it as you see it.
Okay, so just like,
Okay.
oh, this one's kind of hard.
So, do we have an angle
6
bisector?
over x. Yeah, I got
Yes.
it.
Yes.
6.
Alright, so now we have some ways we could see it, depending on how you see it.
Could I say how I see it?
How do you see it, Brent?
6 over x equals 5 over 8.
6 over x is equal to 5 over
You
8.
said. Did I do that
So
right?
Brent saw it like that. Would it be incorrect to see it like this?
No one would see it like that though. It's kind of a weird way to
No,
see
it
it.
wouldn't be.
So could I do 6 over 5 is equal to x over 8? Do I still get the same cross products?
No.
Yeah.
Yes.
I still get the same cross products, right?
Do you
And
really?
that's
Oh,
5x, that's equals 48.
Oh, well.
So either way works. I see it the way Brent saw it, is straight up and down. I'm more of a vertical thinker. So if we cross multiply that, we get 5x is equal to 48. 48 divided by 5,
9.6.
9.6. Good. Okay? Write it as you see it. Grab yourself a practice space. Let's try some of these out.
Alright.
You
Yeah,
may.
I'll get him a